go. Transitioning. How is everyone tonight? I think we are going to be better tonight. Hopefully we'd figure out how to do this tonight better than yesterday. Sometimes it go backwards. And we actually worse than the nights before. But how is everyone? Where is everyone here from tonight? Is this correct? Let's see if our thing is up to date. Oh no, actually we lost a bunch of people. I guess there's only 106 watching now. What's up with that?
Alright, there we go. Now we're live.
Now we're live? Are we live, guys? There's some people from Trinidad already lagging. Come on. Yeah, that's right. You know, I try to install the what is it that we're using to talk? We're using Skype. I tried to install Skype on my older computer over here, and it won't even let me. Like, it says that the OS is too old for that software, so I couldn't do it. I'm like, come on. So I have to do major, like, or either find the old application, right? The old version of Skype, or yeah, or just update to the latest or whatever. Definitely live, says Island Times is in the house.
What's up, Island Times?
Oh, and you're a little low.
It looks clean on my end. So
oh, it looks clean?
Good.
Okay. And let me raise your volume so that we can hear. All right. There we go. What the hell is this? Oh, come on, really? Oh man, come on. My little screen with the things turned on for. Okay, there we go. Pop the chat. Come on. It doesn't. Oh, there we go. Now it wasn't showing me the chat over here. Costa Rica is in the house. Look at that. Curacao. That's Brazil, right? Apparently Skype's turned to crap. Discord's where it's at. Oh, we should have been using Discord. I never tried it, so I don't know how to use it. But then again, I didn't know how to use Skype either. And I do know it sucks, because it sucks.
I know a lot of people are starting to use Discord now. I mean, I haven't looked into it, but I'm guessing it's similar to what Skype's doing.
Yeah, there we go. Does Discord have the video thing too, or it's just the audio channels? Because I went in there, and they're like, the chat stuff is pretty good. It's almost like a forum, but not quite. I think it's a little bit different, but yeah, you can have several like rooms and stuff, and you can talk about stuff. It's it's pretty cool.
I think a lot of people continue chat conversations on Discord after someone goes off alive.
Is that the normal thing that the people do?
I think so. Yeah, I see it a lot on people who play Fortnite.
I see.
Time.
Well, we actually have one. Let me look for the Discord. Somebody has started a Discord for our conversations here, and then I usually post it at the end. But hey, what the hell? Let's post it at the beginning. Come on, Discord. Right. The guy's name is Ian, I think that he did. And I said yesterday, I'm like, oh, I should probably get this. I should probably get this. There we go. By the way, who's playing Fortnite tonight? With
Steve's playing Fortnite.
All right.
If anybody wants to send him a friend request, just
there you
find
go.
Homie to play that on Xbox.
Who wants to beat an old man at Fortnite?
Fuck off, J-Ho.
Or is he good? I don't know. I mean, is he good? Maybe not. Who wants to get beat up by an old
I
man?
blow.
Steve stinks.
He
I
stinks.
blow.
If you kill somebody in the game that is shooting the opposite direction, that's probably Steve.
All my chance.
In the back of the
But
head.
he knows how to talk shit though.
There you go.
This dude's fucking done. Here's our fact. Get the fuck out of here. Oh, my partner.
All right. Well, that's very cool. So, should we play one of the videos? Because I took some time to. I think I did it the long way. I think there's probably an easier way to set up the videos, but oh well. I think they're gonna work. Should we attempt them? Let's see, because I know they don't have a lot of views, so people didn't see them.
Right.
Let's start with number 1. And the sound. Are you gonna be? Yeah, you're gonna be able to listen to the sound. I guess you're gonna be able to listen to my sound. I don't know how are you gonna listen to this. Well, whatever. You already know. You know the sound.
Yeah.
You recorded the video. All right, we're gonna play one video out of 7 that he recorded yesterday at the battery show. Let's explain for those people that are here that don't know what the battery show is. Well, what is the battery show?
So every year in Novi, Michigan, they have what's called the battery show. And the battery show is kind of morphed into a hybrid electric show for vehicles. And so there's 3 different sections of it. There's a lot of stuff on display. And I'm just basically here in Michigan trying to find out the coolest stuff, or what we would be interested in as a DIY group. Unfortunately, the vast majority of the show is geared towards electric vehicle manufacturing. So we're kind of limited on stuff that we would think is cool, but I'm trying to capture whatever kind of advances in technology that we might have now. And what the advances that I've seen are in supercapacitors and also lead acid battery technology. I feel like lead acid batteries technology they fell asleep for a while, and now that lithium ion is catching on so rapidly, I think they're kind of going back and they're adding things, and they're really starting to make lead acid better to hopefully compete with the lithium ion.
Wait, so that's your take? It's like that lead acid is finally getting better now that there's competition, or is this show so outdated that they're still pushing lead acid when the world has moved on to lithium? Although, I mean, this should be cutting edge, right? Because these are the people in the industry. So
yeah. Yes. So my take on the show in general is that I feel like, lead acid kind of turned into AGM now, and they're also using different variations of lead acid. But we found multiple batteries there that actually have ultra capacitors built inside of the lead acid batteries, and those batteries last 8 times longer than a standard sealed lead acid battery. So I feel like if there is some kind of advancement in any kind of battery technology, that it's probably going to find its way into lead acid before it does into lithium ion, just because the manufacturing's there, the capability to be a standalone 12-volt battery is there, and I think that I feel like whoever the manufacturers were of lead acid batteries sees that people are switching to lithium ion and not buying lead acid, and I think they're kind of going back now and investing into some sort of advancement for lead acid technology, because we found a battery from a company called Liach, and they actually started as a battery manufacturer for alarm systems. So when I installed alarm systems, a lot of the sealed lead acid batteries were Liach brand, and that was the elite brand. So that's what you would find in your Honeywell alarm systems and for GE. But now they've gone and they've manufactured a whole line of like super advanced lithium batteries that have a 20-year warranty with them now.
Oh,
And that's like, to me, that's a game changer because they claim that it's still going to cost less than lithium ion.
Oh, I see. Huh, okay.
And you're gonna watch.
I see. So this is a clear example of someone saying like, damn, they're gonna eat our lunch if we don't do something about this. If we don't,
I think so.
If we don't make our batteries better.
Yeah, I think what happened was the manufacturing process expanded so rapidly just because of all the vehicles having SLA batteries. And I think that they just figured that those customers were going to come back, and there's no reason for them to make lead acid technology of batteries any better, you know, and until they have competition, then they have to kind of revisit. So if they want to continue using all the custom manufacturing equipment that they already have, then they have to find a way to make what they're manufacturing better and more competitive.
Oh, I see. All right. So with that in mind, let's look at. I just posted a link on the Facebook group too, by the way, so that people can check it out from that group. Let's see here. Let's play the first video. That was this. These are all videos from yesterday, right? Or the Supercap ones. Yeah. Okay. So these are videos from yesterday, and let's check them out. Hopefully we can totally see. Let's see here. Oh, wait a minute. That's not the one. This is
right. So we're at the battery show here with Steve. That's pretty cool.
It's gotta be homemade.
Oh yeah, this is all custom. For sure. He gets 207.5 miles per gallon. Annual electric cost $264. That is pretty neat.
All the doors look up too.
Yep.
I guess that's where all the batteries are.
I guess. So what we'll do is, if we come back out and the owner's here, we'll have them give us a little rundown. But that looks pretty badass right there. A lot of work. Guy probably put in on that.
As soon as, like, the first day we pulled up, that car was at the very front of the entrance when you first walk into the show.
Yeah.
And the guy wasn't out there, but looking at the vehicle, I'm like, he has to know who Jehu Garcia is, like, for sure, you know? Because it's, like, the same color, and I understand now, like, when you build a car custom, and you spend all that time, and I think I kind of understand why, because every time I see a car that somebody built themselves from scratch, they keep it that color, and it's almost just like, so you can be like, yeah, I fucking built this, and I'm not going to paint it to make it look nice enough to where you think I didn't build it, you know?
So you can still see the insides and stuff. Yeah, maybe.
Yeah.
I don't know. There could be something to it. But those guys are pretty cool.
Like if you painted your van, then people would drive by and be like, it's just a regular van, you know? But I think leaving it like that, it's like, oh shit, that's a lot of work, you know? That's like a lot of hours of work to put into that vehicle, you know? Like that motherfucker is happy that's that color, you know?
Maybe there's something to that. But those guys are pretty cool. I met them at EvCon the first year they were there.
Jones reaction.
And EvCon was, by the way, EvCon was a show in that this guy put together, that Jack Rickard guy put together, right, in Missouri.
Oh, okay.
And so, yeah, it was pretty cool because all the gearheads, everyone that was like messing around with batteries in the early days and stuff, we were all there. You know, they took our cars, and he had a hangar, like an airport hangar, and then we just like drag race, and we just run out there all day. It was just we try to like blow up batteries. You know what I mean? Like it's just. Yeah. It was just like a playground, you know, for people that were like interested in electric cars and batteries and stuff. And then, you know, but the dude turned out to be a jackass, so then, you know, that was the end of that. But those dudes were pretty cool. I actually, when I first saw that car, I wasn't too interested because I'm like, that's a weird, like, looking car, right? I'm like, what's up with that? It's not until after I talked to the guys and I learned, like, what they were trying to do, and then you're like, holy crap, this is a pretty amazing machine. They were trying to, they built it for the X price. Did he tell you that when you were talking to him?
No, they didn't, but I figured.
They almost won it, except that something happened, a mechanical failure. And so it went down. And by the way, the X price, I think, was like $1 million or $5 million. It was like a lot of money that you could win, right?
Yeah.
And the second guy that won didn't even meet all the requirements to even enter the thing. But I think because there was not a lot of entries or whatever, they're like, okay, just let them, you know, like compete or whatever. But I think they were the only ones that kind of met all the requirements to enter that contest. And they due to mechanical failure, they couldn't really win it or whatever.
Wow.
But yeah, they would have, I think, if it wasn't for like some broken axle or something or whatever. But when you talk to them or whatever, you're like, yeah, that car is pretty amazing. I think it used like 170 watt-hours per mile or something like really low, like 150, 170, something like that. And so that car has like a 300 plus mile range, and it could hold it could carry like 5 people or something like that.
So you'll see in the next video. It's the part 2 version.
Okay.
You actually sit backwards, like
2 of the people,
in the back
right?
seat, facing backwards.
Yeah. So let's play that one.
The next video. So the next video is like when we walked out of the show for the first time, and I guess the guy was like going to the bathroom or had some other plans. And then when we came out, he was there, and that's when I approached him. And what's really bizarre is, you know, those prismatic cells that we have.
Oh yeah.
The big ones
that
are like PO4, like 180 amp hours.
Yeah.
So he actually has those exact cells in his car. That's what's powering his car.
Yeah.
Except he has the 100 amp hour ones, and most of the ones that we got in are the 180 amp hour.
Oh, the bigger ones. Yeah, the doubles. So I actually had the 100 amp ones, that size, except mine were like Valcon, because that company split up because they were all fighting amongst each other. So I think these guys, for some reason, they couldn't get like more than 100 amp hours into them. So these were sold as 90 amp hour ones. So they're the same size, same cells.
They just sold them for less capacity.
For less capacity. So that's what I put up in my bus. And when I went to Missouri, when I met them, that's what I had, you know. It's almost the same cells.
Oh, nice.
So let's play the second video here.
All right, I'm going to run the bathroom real quick. Right back.
We left some of it unpainted so you can see what the carbon fiber looks like.
That's cool, man.
A couple pieces.
Did you guys build this yourself?
Yep.
Really? That's awesome, man. You know Jehu Garcia?
Yep.
He built the Samba?
Yep.
Where the
Look on his drivetrain with that. He had an NES-DEA in there at first, just like ours.
Nice.
When he came out to EvCon 2014, I think he was there.
That's cool, man. We're the battery company that he advertises a lot, so That's cool.
Which one? Sorry.
Battery hookup or alarm hookup on eBay, but we're
Okay.
battery hookup now. So that's pretty cool,
What kind
man.
of batteries?
Lithium ion, Life PO4, lithium polymer. We're just a recycler, but we get a lot of overstock and stuff. So yeah, so we get all the modem batteries. If you remember the hoverboard batteries that were everywhere, that was us. So that,
Oh yeah, they were everywhere.
yeah, oh yeah, I know. They're like dollar cells. They couldn't beat it. They're already put together. But yeah, that's cool, man. As soon as I saw this, I was like, just reminded me of Jehu's bus. But we're actually going to be redoing his bus.
Okay.
I think he's making them out of 18650s. So it's going to be
That's a lot of welding.
It is, yeah, yeah,
4,432.
yeah.
4,000.
Oh yeah.
Dang it, that was fun.
I told him he's just going to have to fly to us because we got all our employees there, and we'll build them here and then ship them out there. You know.
Packs.
Yeah. That's what we're doing. Little modular packs. Yeah. But that's cool, man. Very nice. I'll send this to him. I'll see if maybe he can put it up on his channel.
Hey, Jehu, how's it going, man?
All right, take it easy, guys. Will you be here tomorrow?
Yeah, we're here through Thursday. We're presenting Thursday afternoon.
Really? Nice.
We're giving rides.
Okay. Hey, look at that. Prismatics up.
Yeah,
We just got
that's a good
7.
design there.
We just got 7 pallets of these.
Yeah?
Yeah, 180 amp hour.
These are hundreds.
Oh, those are the hundreds. We got the 180s.
Okay.
Yeah. So we'll have them available for like the 180s. Will probably be like $100. You know?
Jeez, that's a good deal.
Yeah. So, I mean, we're trying to focus more because, you know, the 18650s are cool, but they're very labor intensive.
These are Legos.
Yeah. So we actually ordered like bus bars, like aluminum bus bars. So we're going to make our own bus bars, so customers can just screw them together in 12 volt and whatever they need. But I think 4 of them is about 2.2 kilowatts. So it'll be 12 volt, 2.2 kilowatt for like $400, and be ready to go. But we're just right now we're having trouble testing them efficiently because it's a lot of. It takes a long time. It takes like three days to test one battery. You know, but
Well, for that one to self-discharge took 2 years, so yeah.
yeah, I know. Yep. Yeah, that's cool, man.
But we confirmed it. It does have dendrite growth.
Oh yeah,
Self-discharge had to.
a little bit.
Something
Yeah,
pierced it.
yeah. That's cool. That's like the exact.
That's
I
not-
actually think we do have some that are 100 amps or amp hours, but most of them are the 180 ones.
Probably a little newer than that one. Take a look at the number on that one.
Yeah, he's showing me that over there. I should go back and look at mine because I bought mine 6.5 years ago. Yours will have the
What year is that?
Yeah.
Exactly. It's number 29.
That's the 29th one ever made.
Pretty much.
Oh,
in
shit.
those in the blue cell.
Yeah. We got the blue one, and some of them are black. They actually
Right.
now, so
Yeah.
that's cool, man.
So we're still running. I think I've had to take 5 of our original 96 out. So we got like 001 through 096.
Yeah.
And there was a company that sold them to us at cost, which was awesome for the X prize. Ends up they had taken them out of a vehicle, they had put them in and damaged the batteries.
Oh, so you got
then
them.
we got them and we continued to damage them. So
Yeah.
I can't point fingers here because the instructions we got said charge these to 4.5 volts.
Yeah.
And we're like, yeah, all right, no problem. Yeah, until they were swelling and stuff. We had
Right.
clamps on the battery
Oh,
box.
yeah,
back
yeah.
here going, what the?
Yeah, once they look
So-
egg-shaped, it's amazing how like even that thick plastic will expand.
Yeah.
You know.
So of the 96, 5 have died, and there's about probably 17 in here that are a little wibbly wobbly.
And how long have you had them for?
We received these in like May of 09 on pallets.
Oh wow, so you're almost 10 years now, and only 5 of them went bad. How many miles have you put on them?
18,000.
18,000. Okay.
So not many cycles.
Yeah.
A lot of years.
Yeah, a lot of years out of them. Yep. That's
I
cool.
dropped a couple wrenches in there. And crap.
Well, if you need more, just let me know. I mean, I'd love to just send them to you, just because.
Awesome.
You know.
You got a card on you?
I don't. I'm an asshole, and I forgot to bring them. So everybody's been scanning my thing.
Oh, I'm just scanning.
I'm the only guy.
You're the only guy without
Yeah,
cards.
I'm getting like my fat stomach picture taken out of it.
Awesomeness.
All right.
Thank you.
But yeah, just let me give you my cell phone number. Just text me, and then just let me know like what you need, because I'd love to hook you up with stuff like this.
Yeah,
Especially if you already have them. Like, you just need a couple replacements. So I don't mind sending them to you, man.
Here's me.
Oh, cool. All right.
My cell, email, website.
Okay. 217's your cell?
Yep.
Okay.
That's this one.
I'll text you, man.
Awesome.
All right. Well, I'll probably see you Wednesday or Thursday then.
Cool.
Thanks,
Thank
man.
you.
Nice
Good to
meeting
meet
you.
you.
You too.
Hey, guys.
Oh, wait a minute. Yeah, there we go. I started talking before we went like. Well, that's.
Yeah, so he has the gull wing doors installed on all 4 doors.
Yeah.
The back passenger seats, you're actually sitting backwards.
Yeah.
Which is kind of cool. Yeah, I mean, that whole car was custom. Like, you can even tell from just the center console ran all the way along to the back of the vehicle.
Yeah.
And,
it's all carbon fiber.
Yeah.
The entire
the whole
thing.
car.
The entire thing is carbon fiber and aluminum.
I know.
And he had to make all the panels. Like, he had to make everything.
Oh, yeah.
Yeah, that's a lot of work. You'd think, like, doing my buses, I'm like, I started with already a car. You know what I mean? Like, I just banged out,
Right.
cut some metal here and stuff. This dude just made it from, like, the ground up.
All the panels, like the outer panels of the vehicle, those are all custom, you know?
Yeah.
Like, the whole freaking car is custom.
Yeah.
You can tell, but it's cool to see, you can tell just looking at it that it was handmade, you know, and that just adds like it's like a piece of art, that vehicle.
Yeah, well, and it's actually pretty capable. So, like, it can do like a really sharp turn radius, because that was a requirement for the X Games, right? It could carry X amount of passengers, whatever it is. I think it's up to 4, and it had to have like at least like that much like range. I think like over 200 miles or something, which at that time was like a lot, right? You're like, how are we gonna do that? So then they had to look for like a very efficient motor, and that motor that I got is like it's about the most efficient motor that you can get. Yeah, it's pretty cool once you hear their story. There's another video where he kind of explains the whole thing, and you know they should have won that X prize, but they didn't, right? Because they failed, they suffered that. But something that is pretty interesting, by the way. Casey Prince I was at the show today too. What do you think about the CalCam 176 prismatics? Aluminum shell and 3,000 plus cycle life. Only problem, there is no threaded post. Apparently they have to be laser welded. Oh well, it's one of those. They're great for automotive. That's what all the automotive people use. But the interesting thing was when he said that the original instructions, for those that have been doing this for a while, you remember that all the Cal cells, they all came and they're like, charge them to 4.5, volt or whatever. Those were like, they didn't, like the manufacturers didn't know. They were like, there weren't enough testing yet with lithium iron phosphates.
They were so new that they just they started giving them away to people before the testing was done.
Yeah, and the instructions said 4.5 volts, and so we're like, oh, okay. But then people were like, wait a minute, that's not working. They're dying too quickly. What's happening here? Right. They're getting like degraded super fast. These things are supposed to last like thousands of cycles, they're not good or whatever. And it's not until then, I think it was like independent testing that finally figured out that the best way to use them was to charge them no higher than 3.6 volts, right? And then no lower than, I don't know, what was it? I mean, usually 2.7, I think 2.8, something like that. You wouldn't want to go.
The spec sheets now, for the ones that we got in, the low discharge cutoff is 2.5 volts.
2.5. And
the over discharge or the overcharge is at 3.65, I believe.
3.65. Oh, really? So I remember I used to charge mine at 3.6, and later people are like, "Man, you're overcharging your batteries. Like you're hitting that top threshold. Like you shouldn't go that high every time." And I'm like, that's just what I have. You know what I mean? Like, that's what I, at the time when I was playing with them, that was the known thing. You know what I mean? And later, I think people were like, "Nah, let's be more conservative." 3.5, 3.55. Just
3.5 is fine. I mean, I would even say like 3.4 volts on Life PO4 because when you charge a LiFePO4 battery up to 3.6 and you take it from fully charged and you start to discharge it, the voltage drops like super fast. You know, so the usable capacity starts around 3.35 volts. So even if you only charge them up to 3.35 volts, you're only losing like less than 0.5% of storage.
Usable,
you know?
yeah. Mm-hmm.
Right.
Yeah, there's not much
So-
there. Yeah, you're basically suffering all the degradation for not much of capacity. So you're like, why are you doing that? You know, just
You're not losing out on anything. And I think that's the case from what I've noticed with 18650s is like 4.05 volts seems to be where the bulk of the capacity begins, and that's where the curve begins. So even if you charge up to 4.2 volts, like you're not getting anything as far as capacity-wise much more above 4.05 volts. Because if you took a regular cell and you started charging your cell phone with it, and it was 4.2 volts, it would drop down to like 4.1 volts super fast. Or 4.0, you know, it's almost like you can tell that the battery doesn't want to be at that voltage just because it's not accepting any real capacity at that voltage.
yeah, and then it settles down, right? Like 3.5 or something like that, right? Like after a few hours or whatever.
Like super fast.
So Casey says the spec sheet for those CAM 176 are 3.6 upper limit and 2.5 lower cutoff voltage. So yeah, I think that's where it's at right now. Yeah, and I remember 3.65, so I was like, 3.6, it's fine. But I think the philosophy with the DIY cars and stuff is like, undercharge them, under discharge them, you'll be fine, you know? Don't hit the limits, just stay in the middle. And you'll be fine. You don't even need a BMS if you're in the middle all the time, you know? That's how we got away without using a BMS stuff. Let's see here. Should we watch the second one? Oh, I mean, not the second one. The third video? Let's see. This is the second. I don't know which one the third video is, but we could try it. Let's see.
All right, we'll find out.
All right, guys. So I want to show everybody some advancements in the AGM technology. So this is a company. This is EcoUlt. They're basically blending AGM batteries with ultra caps to maintain a state of charge between 30 and 70% on the battery. So that's a AGM with thermal shielding technology. And this battery in particular has a battery management system which will communicate via an app or a computer to let you know what your state of charge is and what the current state of your battery is. So this particular ultra battery has basically a supercapacitor or an ultra capacitor inside. And this is the spec sheet on there. And a lot of AGM technology is starting to integrate carbon. So as you can see, the chemistry is Deka ultra battery, hybrid lead technology, and carbon ultra capacitor. So what the ultra capacitor does is it stores the excess power so that the battery itself can maintain a 30 to 70% state of charge. Now if we go down, what's important here is to the end of life definition. For some reason they're using 70% of original nameplate capacity instead of 80%. So I'm guessing they're just using that number so that their design life can be extended. So it's most likely 7 to 8 years at 80%. But the performance warranty is 5-year warranty or 64 megawatt hours of total throughput, which is the amount of charge and discharge this battery can use.
Solar is charging the battery up to about 60% in the day. It's getting to be a little bit less optimal right now. It's getting to be so he's getting up.
So, as you can see, there's a lot of advancements going on right now, in particular with AGM. And then, here's the different plates that they're using inside. It's a standard grid. That's an arc active grid.
Okay, wow, that's actually pretty interesting. So let's look at the numbers here, because that was pretty interesting.
Yeah, so the biggest thing that I found was that they actually give a number as to like how many kilowatts they can realistically push in and out of that battery, and their warranty covers up to 64 megawatts, I think it was. And I did the math, and considering that you use that battery fully, like in a solar storage type of condition, that battery at 14 cents per kilowatt, that battery would save you about $4,500 throughout the life of the battery.
As opposed to what? Like compared to what?
So if you use batteries to store energy as opposed to buying it from the grid.
Oh, I see. From the grid, as opposed to the grid.
Right. So, and if you use that battery in its fullest, whatever the warranty is, which is 64 megawatts, you would save about $4,500 in energy costs using that battery. So I think that battery in particular, we're probably looking close to $200 per kilowatt,
Oh, yeah. So the other interesting numbers that I saw was the 2,200 pounds, 2293, right? That's a lot.
Yes.
If we divide that, how much is that? 2293 divided by 8.5 kilowatt, right? So
yeah,
8.5. Yeah, you're talking about 269 pounds per kilowatt hour. So
yes.
Yeah, that's quite a bit more than we're used to with our lead acids. The other thing is the power output. Did you notice it was 440 amps?
Yes.
Right? So that, since it's an 8.5 kilowatt hour, that means that 440 amps, that means that it's 177 amp, because it's a 48 volt, right? That was the nominal. So it's 177 amp hour battery. And so at 440, it's about 2.5 C's. So I think that's a continuous, right? Probably. Which is kind of low if you were to like, I think lead acids can do way more than that. Just regular lead acids. I don't know if these are obviously, they're optimized for something else. These are for storage, right?
Yeah, so I asked a lot of questions. Tomorrow I'm going to upload a video from the Liach company, and they have a similar battery, but instead of doing a 5-year warranty, they're offering a 20-year warranty. And they have a little bit more that they did with the batteries, a little bit like newer technology. And so what I understand is that the sealed lead acid and standard AGM batteries will still be what they're using for vehicles. But what they're starting to do is, and what they're very confident that they can do, is give lithium-ion performance in lower C-rated applications, right? So mainly for like a server storage. So like every hospital, if the power goes out, those servers have to stay on because they're monitoring people's health conditions, you know? Yeah. So really every single hospital has some sort of a server battery bank within the hospital. And this is also going to start to spill over, I think, in the coming years, once the price becomes like what it should be, and we'll be able to use that for solar storage, for off-grid applications, and I could even see like kind of what Tesla did for Australia. I think with the newest AGM technology, where they're using capacitors and they're using carbon in it, then we might see larger applications, like a grid style application using these particular batteries.
Oh yeah. Well, that's actually pretty interesting how they're doing all that stuff. Did they talk at all about the price on this battery or not?
Every time I ask, they're kind of like, well, like they're claiming that it's going to be cheaper than lithium ion, or that it is cheaper than lithium ion. But obviously, I haven't gotten any real numbers. But they're like super confident.
You're like, it's lead acid, it should be.
Yeah, I know. Yeah. But I think from what I gathered this week was that by next year, lead acid or AGM technology will be equal to lithium ion, except it'll cost less. And that will be readily available to the consumer at the consumer level.
I mean, if that's true, I'm I don't care. I love the 18650s just because they're awesome, right? Because they mean something to me. Because they allowed me to like dream about an electric car. Even though, well, actually no, I've been rolling around for 4 years on 18650s.
Right.
But a battery's a battery. I don't care where the energy comes from, right? I mean, like, as long as the batteries as long as there's energy. Like, when it comes down to it, like, we want the energy. We're energy whores.
See that tomorrow when I release the Liach video, once I get done uploading it and all, the guy kind of explains about the recyclability of their batteries compared to lithium ion.
Yeah.
I think what a lot of people don't understand that is, let's just say every lithium ion battery that was created from today on at the same rate and at the same growth for the next 55 years, if we don't recycle them properly, we will literally run out of resources to build those batteries. Mm-hmm. And at this moment, when you recover, like when you send lithium-ion batteries to a refinery, you're not recovering 100% of all the precious metals.
Yeah.
Right? You're only recovering, it's a very small percentage compared to what you're recovering from a lead-acid battery. But what this guy said is that battery in particular is 100% recyclable. So he said every little aspect can be reused to rebuild a brand new battery using only the components of the used battery that was recycled. Yeah. So a long period, like I think that's why I really think that lead acid is here to stay, and it's expected to triple in demand from now until like 20 years from now. So I really think that they just kind of fell asleep, and I think that in the coming years, lead acid's going to kind of have a resurgence from a storage capacity level, Yeah. And like I used to be very biased towards lithium, obviously. Like all I do is sell lithium batteries, Yeah. So, but I tried marketing to the RV community, and I think the one YouTuber was like Pippi Peterson or something, and she lives in an RV.
I saw that video.
And she literally turned down lithium-ion batteries. Like a company offered her free batteries, and she turned them down. And like I kind of understand why, because you can literally just connect that battery to your RV and you're ready to go. You don't need a BMS system. Yeah. They're really cheap. And I kind of at that point, I kind of started looking into why, because I wanted to create an argument as to why she would literally turn down free lithium batteries and stick with the AGM batteries, which she's using right now. And it all comes down to price and just convenience and also safety. Lead acid is not going to blow up when it dies, So I think... I'm pretty confident in like 5 years from now, there's going to be a shit ton of our, people that watch this channel and in the DIY community that are going to be building power walls using AGM, and they're going to be super proud of it, you know? Like right now, the pride is like, I built this battery. This is lithium ion. This is what Tesla uses.
Yeah.
But for all those people out there and a lot of the off-grid guys that use AGM batteries, I think they're on the right track. And I think that they're going to be happy with the new AGM technology that's coming very shortly.
Yeah. Well, but what about the puker affair? You got to get rid of that. I don't know, man.
Yeah.
As long as when they get rid of that, then they'll win me over.
I think what needs to happen for lithium to like really take over right now is for all the 12-volt components to go to a higher voltage, you know, or accept the range of lithium, because I mean, right now all the investments, if you follow the money, it's still in lithium, it's still in AGM.
Well, if you think about it, that's the only annoying part right now about lithium. I mean, BMS is still a thing, right? Because there's like, we don't really. Right. I mean, there's a bunch of them out there now, and people are using them. I think people are using them, right? Because I don't think a lot of people are doing what I'm doing without a BMS. I mean, I don't know, maybe not. Maybe I did preach the no BMS thing for so long that a lot of people are doing it. But I think that's going to become a non-issue. I think the thing that it hasn't yet is the fact that they don't work with any of the components that are made for lead acid. And so that's very annoying, I think, for all the RVers, for all the people that just want to use a battery, like without thinking about it, without becoming a battery, without becoming interested in batteries. You know what I mean? Like there are those of us that are like, well, I mean, I want an electric car, but I don't mind, you know, diving in that you know, the rabbit hole of batteries, because I find it fascinating. You know what I mean? But there's all the other people that are like, I just want to put a couple of batteries on my RV, don't have to worry about them. And for those people, I think lithium just because it's just too complex, too finicky. What do you mean they die instantly if you over discharge them too much? You know, like, what do you mean? I could totally do that with my lead acids like a few times and nothing happens. You know,
it really is it's an interesting just the whole DIY movement towards lithium batteries. If you think about it, it's based on Tesla, which is cutting edge technology. You know, like the people who are building their own power walls have so much knowledge that the vast majority of people don't have. You know, like we understand BMSs. You know, like 99% of people who have ever done anything with a battery like have no idea what a BMS is. You know. Yeah. Like, I mean, we're teaching people like how to do cell level fusing, and you know, we're basically teaching them the greatest technology that exists today using the greatest batteries that are available, and it's super complicated, you know. And I think right now we're kind of focusing on the people that are doing it the most complicated way but the most rewarding way. And I think if we started to focus a little bit more on like what a lot of people would consider like the easy way out, like you took the easy way out, you just went lead acid, you know. I think that's because performance wise lithium ion is so much better when you compare it to sealed lead acid. But man, I gotta tell you, like, with just looking at the numbers, like based on and just at the battery show, AGM really kind of dominated that show as far as like advancements. You know, there was certainly a lot of lithium and LiFePO4 battery manufacturers there, but there was a lot of the Chinese brands. You know, they're just grade A standard cells. They're not gonna like hold a flame to a real Panasonic or real Samsung cell.
Oh yeah.
But I think man, I don't know. I was disappointed to show up and not see anything new from a lithium battery standpoint, other than the video you're probably going to show soon is the sodium ion battery, which a lot of people have been asking about.
Oh, I see.
And I got a lot of information about sodium ion, and they actually had them on display and working.
Oh, I see. Let's see. Let's play the next video. Let's see what it is. Playing the Russian roulette with the videos.
All right. So your company's HB Fuller.
Yep, we're HB Fuller. We're an adhesive and sealant company. Been around for about 130 years.
And where are you located?
Minneapolis, Minnesota is our headquarters,
Okay,
but
so
we're all over the world.
All over the world. Nice.
Yep.
Okay.
And right here we've got some battery technologies here. This is a foam encapsulant, fire retardant foam encapsulant that can prevent thermal runaway and thermal propagation.
Nice.
There's the impact resistance, vibration dampening. Here you got a thermally conductive epoxy, so real high bond strength epoxy that is thermally conductive but electrically insulative.
Right.
And used for bonding cells to, say, a cold plate.
Okay. Now, is this a tape or is this
No, this is
band spray?
a two-component adhesive. So the two parts are mixed, and then we have versions that cure very quickly or versions that cure slower, depending on what people want.
Okay. Yeah, so that's really cool because I know if you can use a heat sink and find a way to connect it without shorting it out, you know, like it's kind of important.
Exactly.
So this is cool because if you use thermal cooling around the cell, it's less effective than actually cooling the connections, like the positive and negative, on the battery itself.
Right.
You get, I think there was one YouTube video I saw that gave it like an extra 60% cycle life by making sure that where the power's coming in and out of the battery, as long as that's cool,
right,
then the whole battery stays cool itself.
Sure.
And then, so this right here, this feels like a really hard foam, but this is like a fire retardant. So if one of these cells were to light on fire, it wouldn't set the next one on fire. So if you're looking to build if you're looking to build a power wall and you had an enclosure, you can sort of use this as like a spray foam and spray it in there to fill up all your gaps. And I guess, will this expand?
Yeah, once it's sprayed in, it expands.
So it
about
works
5
just
times.
like the stuff in your wall, like the spray foam.
Very similar.
That's pretty cool. So then that would take safety to like a next level. So even if a lot of our customers right now are fusing individual battery cells at the cell level,
sure,
and none of us have like professional spot welders, you know, so it's super tedious. So it's a lot faster to spot weld nickel tabs, but everybody's worried about what happens if one cell catches on fire, you know, or at least with the cell level fusing, when one cell goes bad, it sort of takes itself out of the equation of the whole pack.
Right.
But something like this would be a solution for people who are worried about it and they didn't build a battery using fusing, then that would just give them like a little peace of mind.
Sure.
You know, but that's really neat though. I like, I think this is important for like e-bike batteries.
Yeah, definitely.
So I actually might be, we're in the middle of getting like a UL 1975 for our facility as a testing facility, and once we get that, then we can start building e-bike batteries, and we want to build like a trolling motor battery too.
Sure.
So I would like, if it's not expensive, I would like to add that product into everything, you know.
Sure.
And then it'll be on the label like we took the extra level for safety, you know.
That's a
pretty neat.
UL94 V0 product too.
Oh, really? So that's UL listed as well. That's cool, man. All right. Well, I'm going to take your business card. And again, guys, this is HB Fuller. And is this product already on the market right now?
Yes.
And how much is it roughly for like a can of air?
Very case by case.
Case by
Hard
case?
to say.
Okay. So if we ordered like large quantity to sell to our customers individually, I guess we can work something out for that.
Yeah.
Okay.
Yeah, it all depends on quantity.
Right. All right. Well, this is an interesting product.
Adhesives and sealants are sold by weight generally.
Right. I think, I mean, this is very interesting, but I know for sure this product right there is something that fits our customer base a little bit. But everybody is looking for some kind of thermal connectivity. So I guess you would make your battery pack, make all the connections first, and then use this to connect to a heat sink of some sort.
Correct.
Okay.
Yep.
And since we're a recycler, so we get tons of aluminum heat sinks that we can repurpose, you know. But that's really cool. So we can do like a DIY thermal management using these products all together. Actually, both of them combined, I think, that's cool.
Sure.
Well, I'm glad there's not a lot of stuff here that we're interested in, so this is like.
Well, glad you're interested in this.
Yeah, this is cool.
Second one.
The cells you're using, they might as well. You need that stuff. You're not Samsung or LG.
No.
Yeah.
This is what we bought them for.
Yeah. All right. Well, thank you, man.
All right. Thanks. Nice meeting you guys.
You too.
Yeah.
Thanks.
You're like, yeah, you're gonna need them with those cheap cells.
Yeah, it's funny. Like he's literally using cells that are known to catch on fire to prove his concept. You know? So I really respected that. But while I was saying that in my mind, I was imagining the eBay listing where you can get like 100 of them for like $50, and they're not even going to charge your cell phone one time.
Yes.
But I think it's important to note, like at this show, I've asked everybody for pricing, and it seems like, nobody gave pricing.
Yeah.
Like, I've asked everybody. Like I even asked for like a rough estimate as to what they're going to be charging for.
Yeah.
Like price kilowatt, and they wouldn't give it. So I think it's almost like they're showing this mainly for the manufacturer, and I think they're hoping to get some kind of deal that's just specific to a manufacturer.
Yeah.
So that's why they're not giving that information. But even this guy, like, this is a product that's on the market, and he wouldn't give me a price.
And I think when he says buy in the market, I think he means like there are manufacturers who are buying it. It's not like it's not consumer product, right? This is not a consumer product. So I think that's the reason.
So he said he'll sell. At first, I went like, now that I heard it again, he said case by case basis.
Yeah.
And that's Steve getting mad at Fortnite.
Yes. I think I think a lot of the business happens like that. It's like, well, how much money you got?
Right.
How much is it? Well, how much money you got? How much can we squeeze out of you?
I guess for that product, we have to buy like, a pallet or a couple pallets of it. But I think that's a cool product because if you build your battery pack, you can, like Tesla runs ribbon through the cells, and they're actually cooling the outside of the shell itself.
Yeah.
But it's not cooled where the energy goes through the negative and through the positive connection.
Yeah.
So there was multiple battery testing some thermal management, and as long as you keep the tabs cool, like the positive tab and the negative tab, and that's where the energy flows in and out, then the whole cell is going to stay cooler as a whole. So if you get 60% more cycle life if you can maintain the temperature of the positive and the negative part of the cell versus keeping the outside hot. Because if you're only keeping the outside hot, then the positive and the negative connections are already going to be hot, and the inside of the cell is going to be hot. So you're only cooling off the outside, which doesn't matter anyway.
Yeah, that's true. I mean, yeah, and then the power walls is, cooling and heating is really not that as important, right? Maybe like heating, it's more important than cooling. If you're like in like really cold temperatures, if you're like, in the northern states, or in Canada and stuff, then you want to, warm your cells. But that's easier done, I think, because you can just use like, heating pads, sort of stuff like that. For us down here, like cooling, I guess, just don't put them in the direct sun. And you definitely don't run them hard, and that's one way of keeping cells cool. So, it's definitely. And the foam was interesting. I mean, that's one way to. That's like I said, Tesla's doing that on the Model 3 modules. So they're doing that like some kind of that foam thing, so where it's just you won't be able to actually get to the cells easily. Was that foam like hard? Like does it turn like epoxy hard, or is it like you can take your thing and you can take a knife and like cut it open?
I would say it's about as hard as like if you tried to push the edge of your shoe in, like at the sole, you know, like it's sort of spongy, but it's very, very stiff.
Ah.
You know, like if you pushed in with your fingertip at the bottom of your shoe, that's kind of like how hard it is. But that product is really interesting because the pack that you have to your left side with the green cells in it, it's a spray foam. So imagine, I guess it would be your right side.
Yeah.
Yeah. So imagine that, and you see like in between the cells, there's little access points.
Yeah.
Like if you know how the WD-40 cans have that little hose that connects to it, and like looks like a straw.
Yeah.
So if you could fill up that just a little bit, and then you let it sit there for an hour, and it will expand 5 times more. So you would build your battery pack, you would squirt that in all the little holes, and then you would put it in your enclosure. And after an hour, the entire enclosure is going to be filled with that. And it's a UL listed product too, so it's definitely passed to make sure that if one cell caught on fire, it would be contained within that substance, and it won't catch the next cell on fire. So I think like if we can get that stuff cheap, you know, and it's only like $10 or something you can add to your battery packs that you're building. I mean, I think that's a really cool product. Just for peace of mind, you know, if one cell goes bad, you know it's self-contained and it's not going to catch the next cell on fire and start a thermal runaway.
Yeah. You will entrap your cells there forever, though. Just think about that, though.
Yes. Oh, yeah. Imagine taking that off. Like, I hate taking off, like, a little bit of glue from the modem packs.
Yeah.
Imagine that.
You're like, screw
that'd be a nightmare.
Although you could probably... Well, no. No, they'll be just make it really hard to get to them or whatever.
It is foam, but like if we started getting packs like that in to recycle and they had that stuff in there, the cells would look like pieces of like shit.
This would be the most hated product in the planet. You would be like,
it's worse.
Curse whoever made this thing.
Yeah, I was thinking about like using that and coating the Sanyo heater cells. You know, and just sell them with like fireproof coating.
There you go. That's right. That's one way to make sure that those don't catch fire. Okay, let's watch another one video. Let's see.
All right, so this is AGM, sodium ion, lithium ion performance at lead acid prices, Faradion, high energy density, sodium ion battery technology. So these are they all going to be shaped like flat cells? Or?
No, they come in all shapes and sizes.
Okay.
That's where the incentives are going. So this is an example of what's inside a cylindrical cell.
Okay.
So these are typical cells that you see in an electric vehicle.
Right, like 18650s.
18650. Okay. Clearly a bit bigger than that.
Yeah. Okay.
But this is an example of how we make the product. And you have an anode, a cathode, and a separator.
Nice.
And they're rolled up into basically like a big Swiss roll, as we call them in England. And that product enables you to put different chemistries and different density of energy and power to produce the same effect.
Nice. And what's the nominal voltage on the sodium?
So it ranges from 12 volt to a 48 volt pack.
Okay.
So you can build effectively a bespoke
by series wiring.
Correct.
So what would these individual cells, would they be 3 volts?
They'll be all different voltage.
Oh, all different.
And again, depending on the density of the material, how many layers of material. So
that's going to go up instead of, whereas lithium ion is always going to be 3.6 volt nominal. So,
correct. So there's a whole range of different energy and different capacity coming out of the cell design.
Right. Now, are these batteries already available on market right now, or?
So the issue you have with new battery tech is you have to build them, you have to run them, and then you have to charge and discharge, and discharge. So we're about 800 cycles on our main production run.
Nice.
So we're coming through, a sensible period that enables us now to start manufacturing in volume. We know we know what the curve's going to be.
Right.
So we're able to provide information around the performance.
That's cool. Are they going to have like the same shipping regulations
That's a major feature of sodium ion.
Okay.
So, as you're aware, lithium ion is a class 9 dangerous product when
Right.
it's shipped. It has to be also shipped with a percentage of charge.
Okay.
You can ship sodium ion with 0 volts.
Oh, nice. So those can be fully discharged.
Correct.
Okay.
So fully discharged, 0 volts means they're very safe to handle, very safe to ship. The other key thing with it is it doesn't suffer from the same thermal runaway project.
Okay.
So effectively, if the cell is compromised, it's damaged in any way, and the two materials, cathode and anode, mix, you're not going to get the thermal runaway challenges that you get with lithium ion.
Nice. Okay, that's pretty cool, man.
So in terms of the power density, it's important to understand it's not going to be as good as the best lithium ion today, but it's going to be comparable between the early stage lithium ion, because we're early stage, really. So we're targeting this at above the lead acid curve, but certainly at lower level LFP.
Right. But they're still going to be priced lower than the lithium.
Correct. They're about 30% lower than lithium, and have if you're looking for something that's high C, high powered, then it's probably not for you.
Right, you gotta go like VO4 or something.
Yeah,
right?
exactly.
Okay.
But if you're looking for something that's, for instance, in the Indian market, they have a lot of low-speed electric vehicles. They currently run on lead acid.
Right.
This is
all the
perfect
mopeds and all that stuff.
Absolutely.
That's cool, man. Okay.
So it's absolutely.
So e-bikes really, I guess, would be a good target for that too.
Yep. E-bikes and plug-in hybrids.
Right.
So something that's not particularly focused on mass power.
Right.
So not a performance vehicles. It's not designed for that.
Okay.
But what it is designed for is that low speed vehicle that just needs to trundle around and get where you go. And also, because you can discharge 0 volts, you actually get more power out of it.
Yeah, you get That makes sense. That's cool, man.
That help?
All right. Well, thank you for your time.
You're welcome.
I'm going to take a few more pictures and everything. And
No problem at all.
so there you go, guys. Everybody asking me about sodium-ion batteries. This is the company right here. All right.
So let's see. Wow, so they can bid this charge all the way down to 0.
Yes, and that's I can't stress this enough, guys. Like, everybody that complains about shipping costing so much to Europe and Puerto Rico and everywhere, that's because shipments of lithium-ion batteries, even if it's just one cell, is considered a Class 9 hazmat shipment, and the price goes up exponentially. Right, so these batteries can be shipped at 0 volts. So even if you shorted them out, they can't possibly do anything. They have no power in them. So these batteries will be able to ship unregulated, just the same way as like a AA alkaline battery. So I can basically ship these batteries inside of like a priority mail flat rate box for whatever the flat rate cost is, like $11. And also one interesting thing that I got from this is that with sodium ion, the larger the battery gets, the higher the voltage it is. Whereas with lithium ion or FiO4, like an 18650 cell will be, for instance, 3.6 volt. But then a prismatic cell that's the size of like an encyclopedia is also going to be 3.6 volts because that's what the chemistry gives it. Whereas sodium ion, the voltage increases the larger the battery becomes.
I don't know if that makes sense, dude. I don't know if that makes sense, because what if you parallel 2 cells? Do you know what I mean? Like, how is the voltage going to go up?
I think with sodium is that the voltage range is going to be super high because you can discharge it to 0 volts. And you're going to have a lot of capacity even at like 0.1 volt, So I don't know how well this is going to work. I don't know if it's going to work good. Like, obviously, it's going to be a bad battery for inverters that have an input voltage range.
The range has to be super high. I think that's what it's going to come down to. All right.
So I'm questioning the like what applications they're actually going to work well in, because if even like an e-bike motor that's, let's say, 36 volt e-bike motor, a lot of people are upping it to 48 volts and it still works, you know.
Yeah.
But I think if you go up to 60 volts, then for sure that motor is probably going to start acting bad, you know.
Yeah.
So I mean, I think they're going to have a discharge curve where you're going to see where the bulk of the capacity is. But there's definitely going to be some type of capacity from 0 volts to, like, 1 volt, and that's going to be unusable for most applications.
Oh, yeah. So, yeah, that's going to be kind of messy if indeed that's how it works. Yeah, it sounds interesting. Definitely.
The good thing is, though, in my opinion, is if this technology does take off, even if it's like 10 years, 20 years from now, and this becomes the best way to have like a battery that's better than lead acid. So let's say 20 years from now, everybody realizes, oh my God, like we're not recycling lithium ion batteries properly. We're going to run out of these precious metals. We're not going to be able to make them anymore. Then sodium ion is readily available. It's literally using salt. It's 100% recyclable. So if that's the case, then the inverter companies and all the applications that this battery would apply to, they're going to have to start accepting a wider range of input voltage. And that's going to make it more, I think that's going to make inverters and other type of like charge controllers
work with everything.
Universal.
Yes.
So that's what we need. We need more range of input.
Yeah.
So we're not like with 12 volt batteries, like it's ridiculous that.
Or we need adjustable, programmable voltage range, because I think a lot of the equipment can easily be right, but they're not. They're made for a very specific battery, like lead acid in this case, right?
Yeah.
So they have to build those hard limits at the top and the bottom because those are unsafe according to the battery that they're designed to, right? But if they give us the freedom to just like, no, I'm just using some other type of battery, I need more volts out of or more range out of this equipment, then it just put a knob there at the top and the bottom, then you're it'll work that way.
I completely understand why you wouldn't want lower volts to be like, if you developed an inverter, obviously you're using parts that are meant to carry a certain amount of amps. So the lower the voltage, the higher amps that you're going to need.
Yeah.
So I would say like, all right, maybe 22 volts would be the low point on like a 36 volt inverter.
Yeah.
But why are they programming it to not accept 100 volts? Like technically all the components inside.
Well, not all of them, dude.
Because
I went through that when I was playing around with that charger. So when you design, there's a bunch of stuff like caps. There's a bunch of things that are like work better within a certain volt range, right? So if you get below that or above that, well, above that they'll blow. Below that, they're just not as efficient. They don't do the right thing, right? So you can build a range, but you can't be like crazy range. Which I mean, I guess with some good design and some clever things, you could get to a point, right? Like our Alcon chargers, they go from like 48 volts all the way to like 450 volts. So that's crazy range right there. Yeah, that's a crazy range.
You're saying that makes sense now, because so I guess what you're saying is like, for instance, an inverter, it's although the components can carry, obviously they can carry the lower amps, because if ultimately your output is watts and it's a 5,000 watt inverter, then the higher the voltage is, then the lower the amps is going to be, and in theory
it'll just be less efficient. Like it'll be like I don't know, like 90% efficient or 88% efficient at from this voltage to that voltage. Anything below that, it's just you're like, so it's a 5 kilowatt charger, but you only can get like 3.5 because the rest is just being burnt in like heat, because it's out of range of most of the components. It's like out of that sweet spot.
So what you're saying is the individual components that you're using within the inverter are not they're not designed for higher voltage.
Yeah. Or they'll be too costly to have like two types, right? Like two sets of capacitors, right? If in your design the capacitors are what's like really expensive, then you
Right.
don't want to use two banks, one just in case that the the operated. So I think that's why they like make two models, right? Because they're like,
okay.
we'll just put another one over here, one over there, because it's just designed for that range, and it's just a lot easier. It's a lot less expensive to build like a universal thing that works
Right.
on every voltage. It just kind of doesn't work that way. And I remember when I was doing that on that charger, that was the way, because that guy was scratching his head trying to figure out how to give that, right? Because people were like, no, we need something that works on batteries that are 48 volts and on batteries that are 500 volts, and he's like,
Yeah.
you can't do that, It's like, I mean, you could, but it'd be really expensive. You just gotta pick one, like he's like,
Right.
it's just easier to pick the right thing for the right job, the right tool. But yeah, that's definitely interesting on those batteries. Let's watch another one of the videos, because it's gonna be 10 already over here. What time is it over there? It's like 11, 12.
It's about 1 o'clock in the morning.
Oh my god.
Oh. Yeah.
Is anyone still watching? I can't see my thing.
I had a thought before, and I totally forgot what it was. It was regarding the sodium batteries. As I asked the guy in particular, all these new technologies that they're showing, I'm asking them why they're not in market yet, because we always hear about the newest battery, and it's going to end up, like, everybody's saying, oh, this is going to be the best thing since sliced bread, and it never comes to market. So that guy, I asked him, specifically, I said, is this to market yet? And he said, no, we're only at 800 cycles right now on our testing process, and that has to be duplicated 20 times.
Yeah.
So all the new technologies that are coming out and everybody gets wind of, it's going to take a long time for these batteries to fully finish their testing processes so that they can get all the certifications to be able to sell the battery to the public.
Yeah.
So although in theory these batteries are working and all these little different chemistries are working, in order to take them to market, there's so many tests and it takes so long that's why it takes so long for this stuff to actually come to market. So I know, like, the last couple of years we've been hearing about all this new stuff, and one of them was the sodium batteries, and it's funny that they were actually there this time showing them off, showing off the prototypes.
Yeah.
But that's why. So I have a feeling in like 3 or 4 years, all these batteries that were like, I'll believe it when I see it, like, I think they're going to actually start coming,
Yeah. Well, that kind of makes sense. Products are not easily put out into the market. You got to do a bunch of testing. I'm going that through my little PCB, it's like very quickly. I'm actually glad I didn't make it like widely public. I haven't made the video and make it like super clear how to go and get the thing. Only some of the brightest guys are able to, like, here's the thing, put 2 and 2 together or whatever. As it turns out, there might be a better connector, and the connectors that we're using are kind of, wimpy and maybe low quality. So we might be able to change them, and I'm looking for, I ordered some stuff. So, I mean, this is just a stupid little PCB that connects some batteries together, right? I could imagine, like, stuff that, has to have, like, chemistry,
Oh, yeah.
The chemistry, like, that's a little bit of magic that happens, right? When elements combine together, make different molecules, and then interact. Like, I understand the basics of that.
Yeah, I can understand the feeling too. Like, if you're like a chemist, and you built this battery for the first time, and you developed this whole little thing in a fucking jar, and it works. You're like, holy shit! I gotta let everybody know that this works,
Yeah.
And that gets the ball rolling for all this, like, skeptic stuff going on with the internet.
Yeah.
And people are like, yeah, fuck you, that's not gonna happen, this is bullshit. And the guy's like, no, like, I literally did it, but I can't talk about it, and I can't even push this product or market it until it passes all these levels of testing. And the harshest one is that battery has to get cycled until it dies. And if that's a really good battery, that could be years and years and years from now.
How?
So it's almost like, man, like,
just give it to us.
20 years from now, this battery might come to market because they couldn't figure out the end life of the actual cell, you know?
Just give
Like,
it
if
to
it's
us, man. We'll cycle it for you, man. We'll put it to the test.
Yeah.
Learn from Cal.
Yeah.
They did it back in the day. All right, let's watch another one of these videos.
This is V-fill. It's actually really nice right there. Look at that. Just looks cool. Like if I owned a Wawa or a coffee shop, I'd want one of these things out front.
Right location to tell the difference.
You just got two of them. They got different connections. See, this one has that connector.
Yeah, okay.
Chatamo.
How far you got?
And this is CCS.
Okay.
50 kilowatts DC. It can.
Lots of power in there, right?
Yeah. So there's that one. Here's the other one over here. I mean, this is cool, man. These things are gonna pop up everywhere.
Oh yeah. We're all over California, remember?
Yeah. That is pretty neat.
Those are actually the cables that connect those. Those are the ones that have liquid lines through them. Because they gotta transfer 50 kilowatt up to 50 kilowatt through that tiny little cable. I mean, you know what I mean? That's a lot of power. It's like
you have to actively cool it while it's flowing through.
Yeah, the CCS combo, whatever. Just yeah.
There's multiple displays of those, like EV chargers, and man, they're like really cool looking. There's another one that I'm gonna go back tomorrow and get some footage of, where the whole thing's like a touch screen, and it's it looks like a flat screen TV. Like you'll probably watch like the NFL game while your car's being charged. You know,
Yes.
like they put so much effort into the design, and it's like the most sleek, like coolest looking things I've ever seen. You know,
there you go.
because it really is pretty basic. It's just a charger. You know, like it's not very complicated. So the trick for them is to make it appealing to where people are like, that looks really fucking cool. You know.
Yeah.
And so that's the only reason why I captured that, is just to show people the design of all these new things, and everything's having like little LCD screens and LED lights to make them look cool. And I could see them popping up like at different places, you know, like at coffee shops and Panera Bread and all those.
Yeah.
They're gonna start popping up everywhere.
I hope so. I mean, yeah, we got to make it happen so that we can charge.
Yeah.
I actually have a video of us charging in the last time that we charged at a thing, but it's in my phone. I never put it on my computer. I'm so unprepared.
You actually charged your bus from a Tesla charger?
No, not from a Tesla. It's just a regular, regular charging station or whatever.
Okay.
Yeah, you can't charge any other car on a Tesla yet. They haven't opened that up. Yeah, not yet. I think eventually they will.
You know what I think's gonna happen, and I don't know if it's been developed yet or if it's in development. Like every parking spot needs a parking block, right? Like so you can't drive over it and hit the building.
Yeah.
So all those little park blocks that you they're like 6 inches tall and they're right in front of the curb. Like I think those eventually will be the chargers. So the little charge port's gonna stick out the side, because I think the whole trick to making everything electric is to not have all these little chargers popped up everywhere. You know, it's going to look tacky. Yeah. But if you can integrate that charger to where it literally comes out of a little, like the bumper that's in front of your car when you park.
Yeah.
Like that would be cool. So I think that design to where Like if you looked at a 7-Eleven or a Wawa right now, and using that type of product, looking at that same store in the future, it's not going to be covered with all these, you know, large things for charging your car. I think it's got to be blended in with like what the environment that we're used to having right now.
Yeah. I mean, I think the challenge is more like the actual connection. Because, you know, like those can put out like 50 kilowatt. I mean, that's what an industrial business, you know, that's what you use on your entire like business, you know what I mean? Like,
yeah.
And you probably don't even hit like 50 kilowatt at any time. Like, so that one car is using
So
at any given
imagine
time,
this.
you know what I mean? Like,
And this is another thing like I was thinking of. If your charge port was actually on the front end of your car, like below where the hood would be, and you pulled up into a parking spot, and that parking spot, like where the bumper would typically be, that actually kind of just came up and connected itself to your car, and you had a little account to where every time you parked, whether it was to go in and get milk or bread, like, and your car was off, then that actual parking block would be charging your vehicle actively. Like, would just automatically do it.
Yeah.
That would be pretty cool.
That would be pretty cool. It's just, to make it happen, you need one of those robots that will find your port.
Yeah.
Right? Or you'd have to do like these little lines or whatever, like when you go through a car wash, or like it forces your car to go in that one specific spot or whatever. I guess that would be.
I mean, since the parking blocker thing is like the width of the whole parking space, it could just be something that like shifts left to right.
Yeah.
You know, like even if you park off like a foot off to the one side, it'll still be able to connect. And it'll just be something that like lights up and it just knows that's the port.
Yeah,
that'd be really cool.
It'll be like the little snake that, you know, that Elon.
Yeah.
Oh, there you go. And then it'll start having sex with your car.
Like every time you stop somewhere, like a gas pump would just magically connect and start filling your gas up again for you, you know?
Or, you know, we can just like import a bunch of Mexicans and then we could just hire them to like...
That's true. We'll have them lay down or wear stuff that blends in with the building colors, you know?
It just take one and you can do a whole parking lot, you know? You just plug, unplug.
Or
you know?
we can dress them as little bushes and trees, you know?
Camouflage. There you go. You just stick out your hand, you're like, plug it in, there you go. All right, let's watch the last video. You uploaded 7, or I had downloaded 7 videos, so let's see here.
There we go, ultra capacitors. How you doing? There we go. Nice. Is that a full ultra capacitor battery bank? Or bank? Okay. Nice.
It is made by the electrode.
Okay, that's the electrode there?
Yeah, this is our unique method.
Okay, nice. Do you make them in 3 volts by any chance, or is it all 2.7 volts?
3 volts.
That's 3 volt?
Okay, sir. 2.7 volts.
Okay.
2.7.
Do you make them in 3 volt by any chance, or?
Oh yes.
Okay.
And in the future, look, that electrode is going to make 3 volts cells.
Okay.
And now this is all of them are 2.7.
Right. What's the price roughly on the 3,000 farad? The large ones.
The larger ones.
Yeah.
It depends on how many units you need.
Like how much for about 1,000 of them? 1,000 of the.
The small one you mean?
No, the larger ones. I guess it would be the 3,000 farad.
Yes.
Yeah. What would the price be on those?
The normal
roughly.
price.
Yeah.
Okay. Reference price, right?
Yeah.
Jason, how about the price for that 3,000 farads? The reference price?
3,000 farad. It's retail prices for one is $75.
75. Okay.
It is
Not
the
bad.
finest ultracapacitor on the market.
Nice.
Explain to you, but if you need something that absolutely positively cannot fail, that is competitive with the other brands.
Okay, so you would say that those are better than the Maxwell brands,
Yes,
or
our principal was the chief of R&D for Maxwell.
oh, really nice.
And then she left with some better, some she developed, after she left, she developed some really better
Much
ideas.
better. Okay, nice.
So Maxwell's awesome.
Yeah.
We're awesomer.
Okay, nice.
That's what I'd say too.
So take a look. It's like it's shown here. It's shown here.
Make sure that you get these guys
Yep.
in their, you scan them? Okay.
Yes, yeah.
Have it?
Thank you, ma'am. Thank you for your time.
And take one
Okay.
business card.
Cool.
Jason's.
Okay, thank you.
See you.
Yeah. We look like slobs here.
Oh, you're big and you don't have no cars. Fucking CEO and you have a car. You're an idiot.
All right.
$10 for 500.
Yeah. Yeah, guys, so me and Steve are here. We're the worst dressed people. We look like douchebags, and I don't have a card on me for business, so. But we're here for you, because I don't really... This is all the stuff that we're going to be powering our houses with 5 years from now when it comes through our facility.
Yeah, a bunch of suits there. What's up with that? I don't belong there. I'd be.
Yeah, I'm telling you, not like I swear to God, I didn't see anybody there with a T-shirt. Like everybody is dressed to the nines, right?
Really?
And me and Steve are walking through this place like scumbags, right? And I don't even have a card with me, so like I'm morbidly obese and I'm wearing this thing that like hangs over top of my stomach. So all day long, I'm just having my fat stomach getting taken pictures of from cell phones. It's like super embarrassing. So I learned two things for sure. Next time I gotta, go shopping and get like a button-up T-shirt, or at least
suit,
just so I look presentable.
Yeah,
so I'm not walking in with like a battery hooked up regular T-shirt. It looks like a skateboarder shirt, and like DC shoes,
No, man.
And also,
these guys are posers. These are not real battery guys. Just look at her.
They're all looking. It's super weird. Like I mean, I don't belong in that corporate world.
Yeah.
It really is like a whole nother world. Like you can see these people that are there as a group, and like they're normal people. Like they're normal people. Like you can go out to the bar and drink with them and bullshit with them. But in that setting, they have to act like somebody that they're not.
Like robots. Robots.
Yeah, they're really just corporate robots everywhere, and it's super uncomfortable.
Oh no.
Just talking with them. But there was like one other company, like the guys were really cool. I don't even know what product they were giving out, but they were actually serving beer and shots.
There you go.
Everywhere you go, somebody's either handing out candy or handing out like battery samples or something, But this company, these guys were fucking hammered, and they're just giving away free beer to people, and just sparking up conversations that have nothing to do with the product that they're selling. But like they're just there to have a really good time.
There you go.
But with the supercapacitors, the one thing you got to take out of that video is that most of the supercaps that we're all using right now are at a 2.7 nominal voltage.
Mm-hmm.
And next year, there was multiple companies there showing their latest technology, which is actually bringing up the supercapacitor voltage to 3 volts. So if you put 4 of them in series, it's going to make a perfect 12-volt replacement, and they're coming out with these supercap batteries that are just basically car batteries that would last the lifetime of 20 cars, like you could, like your grandkids could pass that battery down to their grandkids, or the supercapacitor battery,
Yeah.
And that battery, or the supercap as an assembly, is just going to last and last and last for millions of cycles.
And it's great because lead acid batteries or automotive lead acid batteries, they're just made to be topped off, and then every once in a while you use a little bit of energy, a lot of energy. you know, to
You
start
need just
your
enough
engine.
to start your car.
Yeah.
You know, like
That's it.
That's the biggest thing. Other than that, like, well, super caps you can charge within seconds, right? So if your cell phone had a super capacitor instead of a battery, you could charge your cell phone in 5 seconds, and it'll be fully charged. You know, and I
But
think
you would have to charge it every few hours because the energy density
Right.
is super low still.
Exactly, yeah. So your phone would only work for a couple minutes, but you
No, I mean, I think a couple of like hours or something, yeah. And then you'd have to like, oh my God, let's charge this thing again because it's down at 10%.
Yeah,
but
I'm like a firm believer that, you know, maybe 50 years from now, or I think super capacitors, the way they're built, if they continue to improve, you know, they would completely, like, batteries would be a thing of the past, you know. And I think there's a lot of promising developments coming up, and I know it's only going to get better. So I could see maybe 10 to 20 years from now, we're going to have discussions about, should I build a power wall using supercapacitors because it's going to last my whole life, my kid's life, you know, like this house, far after the house crumbles to the ground and turns into dust, the supercapacitor is still going to be creating energy.
That's what, you know, that's what the kids are going to be fighting over.
Yeah.
You know, it's my dad's supercapacitor bank. No,
like the sister's gonna get the house, and the brother's gonna get like the capacitor bank,
and they're gonna be hating each other. Like, no, he left it to me. How dare he?
Right. You know, great grandfather John left me this. You know, like let my great father this battery. This is mine. They're gonna be going to court over supercapacitor banks.
Yeah, all the ones that didn't make a clear, you know, whatever. What's that, wheel or whatever? Yeah, I mean, that's cool. So yeah, 3 volts would be a lot better. Cause how are they doing it now? Like, I've seen people do some tests, but on what is it, 275 or what'd you say? What, 2 volts? Yeah, 275, right?
Right now they're 2.7 volts, but supercapacitors can be discharged down to like 0 volts. You know, like they can fully release. It's sort of it's going to be similar. And now that I think about it, with sodium batteries being able to go down to 0 volts, maybe they would eventually, in the future, pair up with supercapacitors to give them the extra power. So sodium batteries, I was like really strict about telling me like multiple times that this is not something, you're not going to be able to start your car with these. You know, this is strictly for capacity. You know, they don't have a high C rating, but they're going to last super long, you know, and you can discharge them down. They're going to be very safe. They're going to ship super cheap. So maybe in the future we would have a hybrid between sodium ion batteries and supercapacitors, and the supercapacitors would be integrated to give the sodium ion batteries some extra power and extra juice.
Yeah. I mean, that's the way to do it. Right there, that's what people want, right? Like, although unless if you only need it for a short burst power, you know, then that's what you have to do. It wouldn't be.
So I mean, the energy storage is getting to a point where it's starting to make sense because the AGM batteries that we showed, they have ultra capacitors actually built in.
Yeah.
So the ultra capacitors are being used so that the AGM batteries are only being used within 30 to 70% of its state of charge. All the rest, like whether it goes below or higher, all that energy is basically coming from the AGM batteries. So or not the AGM batteries, the supercapacitors.
Yeah.
So the supercaps basically charging the battery slowly and releasing that energy so that it never goes above the 70% state of charge or below the 30% discharge.
Yeah. Oh, I see. They're saying, watch Jacob cut up his jeans. No, I'm cutting my dog's hair because he's bugging me. He's like wants me to go play with him, right? And I'm like, oh, I'm gonna take this opportunity and cut his hair. You know, he doesn't let me cut his hair, so
you get dog grooming lessons while you're looking at your supercapacitors.
Yes, and he's just staring at me. He's like looking at me like, "Are you done yet?
Yeah.
Are you done yet?" And he's been here for like an hour. I'm sorry, boy. Well, with that said, it's 10:15 already. I say we call it a night. People are not even listening to us anymore. Let's see. Who's on? I see no comments. It's been like two minutes without comments. Let's see. Oh, damn, there's 160 people still watching. That's crazy.
Battery.
You guys are crazy, man. You guys are crazy talking about batteries.
Also, what's funny is Maxwell is actually there.
Oh.
Right?
The
guy literally talks shit about Maxwell. So tomorrow I'm going to take that footage and I'm going to show the Maxwell representatives what that guy said. I'm literally going to point at them because they're within, they can see.
They're across the aisle.
I'm going to download like gangster music into my cell phone. And I'm going to be like, oh shit, look what he said about you,
Start some more, yeah.
But my goal is to bring one of them over to the LICAP stand and have them start battling it out. Who's better?
Yeah. Well, but they're suits, man. They're gonna be like this. That's how they fight.
Yeah. They're gonna choke each other out with their ties.
They're gonna go like this. They're gonna try to dump the water on each other, like.
Because the reality is that company is like 3 times more expensive than what Maxwell is offering right now.
Yeah.
He literally said that Maxwell is awesome, but his are awesomer.
Awesomer. Wow. He's making up words.
And he said if you want a product that you can, basically trust for years to come, you want to use ours and not Maxwell. So I'm going to take that footage to Maxwell and hopefully start a huge fight in the middle of the battery show.
Just try to make it where we get a bunch of like free caps.
Yeah.
Hey, he said that. I got to put it to the test.
Open the box truck.
Oh, that's right. You did right. Fill it up.
Yeah. So what I'm hoping is like maybe people don't want to ship their products back, and then maybe we can wait around end of the show and ask them if we can take their displays and all that.
Oh yeah, just tell them, hey, we'll take it, we'll drop it off. Where are you guys at? We're heading that way. California? Yes, we're heading that way. You fill it up with a bunch of batteries.
Yeah, don't worry. Yeah.
There you go.
But just the displays, a lot of the displays are really expensive, and I know. I don't see every one of them just packing it up. Like all the things that like hang from the ceiling, and they got all the LED lights on them.
Oh yeah. Oh dude, yeah, those cost an arm and a leg.
I don't know if you guys heard it, but Steve busted ass, and it was super loud.
Oh really? Oh, we didn't. Man, you were talking.
Damn it.
Damn.
It was a good one. You guys missed it.
Now
I have to smell it for the rest of the night.
Your mouth fart, blocked his ass fart.
Yeah.
That's what happened. All right. What are we calling our night? That's it. That was cool. You're gonna upload more videos? You took a bunch of it today, right?
So we're gonna do some more filming tomorrow.
Okay.
I spent a lot of time like walking around and continuously filming, and I didn't get the footage that I wanted. I got sucked into these long conversations with like people who had products to sell that I couldn't care less about.
Oh yeah.
And so tomorrow I'm gonna go to my favorite places. There's one battery that like you can drop from like a helicopter into like a war zone or something, or like if a hurricane hit.
Oh, it's like a package thing.
To drop these down.
Yeah.
Yeah, they look like ammo, like huge ammo crates that would drop out of a plane on a parachute, and it's basically storage of power. It's this big battery with an inverter, and it looks cool. It literally looks like something that the Army would use.
Dude, we have to make some. Yeah, take pictures. Take a pencil.
Really awesome.
Take a pencil.
Oh yeah.
Put it next to the thing. Then take a picture, and then we can. Yeah, let's make some. I mean, those would be cool. We put foam around it. Yeah, I mean that sounds cool. I want to make. We'll do them with the lithium iron phosphate cells you got there. Those are like super safe and indestructible.
Oh yeah.
And cheap, hopefully. So that's what we should make with one of those.
You can get really big ammo crates, like the ones that hold like rockets. Like
I had two of them.
Huge.
What happened to them? I got rid of them. I literally had the rocket ones.
Nice.
Because I wanted to use them to put batteries in there for the bus, right? But then I'm like, screw this. I don't want a big giant boxes, you know. It's like, I'll just put them under the floor. And so then I was like, get rid of these things, you know. I had them here for a long time.
You could save them. We actually got a bunch. I think we have some listed on eBay right now, like the 50 caliber ammo cans, but they're perfect for batteries because those are made specifically as like in case the entire round of all the ammo set off by themselves. Like they're made to withhold like an explosion, the fire. Thing.
Oh, I see. I see.
So they're perfect for lithium battery storage. Like if the lithium battery caught on fire in there, you would get a lot of smoke, obviously.
Yeah,
but the flames wouldn't come out of the can, and the can wouldn't explode.
There you go.
But yeah, that one that you had, you could have probably fit like 20 kilowatts worth of batteries in there, and it would have been safe. You know.
Not in lithium iron phosphate. I remember I did the math, and I'm like, oh man, I'm gonna need like a couple of these, and I got a couple of them, and they were kind of heavy, right? And I was like,
they are heavy.
They're heavy. They're like big, thick steel, you know.
Right.
I had them for a long time. I don't know what ended up happening. I think I just sold them like on a yard sale or something here. I was just like, gave them away. I'm like, give me $5 for them or whatever. I paid money for them, like $40 or something. I don't know.
They don't recycle them like that. Those are used one time. At the manufacturer, and then they collect and they end up on like eBay government. Or not eBay government, just like government auction websites, but you have to buy like a truckload of them, you know?
Yeah.
If you have to buy like a ridiculous amount, but they're basically selling for about the value of what the steel costs, you know?
Steel, yeah.
But they're really good enclosures. I bought a couple pallets, and I might buy some more just because I think it's a good product for people to have. It's cheap that they can use as an enclosure for their batteries.
Yeah.
Like just in case. I think they'd be cool for e-bike batteries and stuff like that.
Yeah, I mean for camping or just like an industrial type battery pack, you know?
So they have the handle on there, so like you can just carry it, you know?
Yeah.
It's pretty nice.
All right, man, let's call it a night. I think it's a good one, and we'll do tomorrow. We'll do some other videos. Get those guys fighting each other.
Right.
Or you know, so I don't know. Try to get that on video. Get Steve.
All right.
Join him. You might have to join him there and then hand the camera to Steve so that we can have, the shot.
Nice little pattern.
Yes. All right, everyone. Good night. Thank you for spending some time with us talking about batteries and shenanigans. This battery show seems pretty cool. I missed it, but, we didn't because Tom is there. And, we'll get to see today's in tomorrow's video, and hopefully it'll be as fun as today's videos. All right, man, we'll see you. We'll talk to you later.
Take it easy. See you guys.
Okay, good night, everyone.